Welcome back to the breakdown box. Today we are going to explore how Splitwise simplifies group expenses. When you go to a party or head out on a trip with friends, there is usually a lot of back and forth with money. Someone's covering for lunch, another friend is paying for tickets, and maybe someone else is handling gas. But when the trip is over, figuring out who owes whom and how much can get pretty confusing, right? And that's where Splitwise comes in. It simplifies everything by calculating minimum number of payments needed to settle up. Instead of each person paying everyone back individually, Splitwise groups the amount into just a few transactions. So what does minimizing transaction mean exactly? So imagine if instead of 6 different payments between friends, we only had 2 or 3. It's cleaner, faster and way less hassle. Let's break down how that works and why it's useful. There are a few different ways to minimize transactions. But today, we'll explore an approach that uses something called heap. Don't worry if that word sounds unfamiliar. First, we will get a feel of what heaps are, and then we will see how they help us in simplifying transactions. Alright, so let's dive into heaps. First up, why do we even use heaps? Heap are a tool that helps us manage values in a specific order, making it easy to grab either largest or smallest value in a group. The key stored in each node is either greater than or equal to or less than or equal to the keys in the children's node. Let's understand this with an example. In max heap, every parent node is greater than or equal to all child nodes. And we can see this property holds true for all the nodes. Min heap is just opposite. In min heap, every parent node is less than or equal to all child nodes. And we can also see this property holds true for all the nodes. This comes handy when we need to quickly find who owes the most in a group. Now that we understand heaps, let's see what happens when we take the top value from a heap. When we remove the top value, whether it's from a max heap or a min heap, the other values in the heap adjust to fill that space. This means that the next largest or smallest value rises to the top, creating a new top for the heap. Let's look at it in practice. For example, if we start with our max heap of values, let's say we remove the top value, which is 40. After removing it, the next highest value, which is 20, moves up to take its place, and the heap reorganizes itself. Similarly, in min heap, if we remove the top value, the next smallest value moves up to become the new top. These adjustments keep the heap structure intact, ensuring we can always access the largest or smallest value easily. Now that we know the concept of heaps and how to extract value from them, let's bring it all back to our initial challenge, simplifying transaction among friends. Picture this. We have a group of friends and each friend has either paid for someone else or is owed some money. We can visualize these transactions using a graph where each friend is represented as a node and arrows shows transaction between them. Here A gives B $10, B gives C 20 and so on. For each node, we will calculate the incoming and outgoing values, essentially figuring out how much each person is owed and how much they owe. For friend A, outgoing is 10 and incoming is 15. Therefore, incoming minus outgoing is 15 minus 10 equals 5. Similarly, we will calculate for other friends. Let's break it down into two tables. The first table will list friends who are owed money, and the second will list those who owe money. Here, minus 10 means they owe minus $10, which essentially means they will get $10. And what's particularly interesting is that when we sum up all these values, the total value will always be equal to 0. This property is crucial for understanding how we can simplify transaction effectively amongst our group. And now that we have calculated our incoming and outgoing values, it's time to put this information into heaps to simplify the transactions. We have two tables, one for those who are owed money and another for those who owe money. Let's create heap for each table to make it easier to keep track of who owes the most and who owed the most. Max heap for positive values. For the table of friends who have to give money, we will create a max heap. This is because we want to prioritize collecting money from those who owe the most first. By using a max heap, we can easily access the highest amount owed and collect that debt before moving on to the next. This ensures that the friend who owe the most pay back promptly, minimizing the number of transactions. Here D owes 10, A owes 5 and C owes $5. We have marked each node with friend's name because we want to track who has to pay and how much. min heap for negative values. For the table of friends who are owed money, we will create a min heap. This is because we want to prioritize returning money to those who are owed the most first. By using a min heap with negative values, we can easily access the largest debt, most negative value, and return that amount before moving on to the next. This ensures that the friend who are owed the most are paid back promptly and minimize the number of transactions. In this case, B is owed $10 and E is owed $10. Here also we have marked each node with friend's name. This helps us see who has to get and how much. And by structuring our heaps this way, we can manage the payments in an organized manner, ensuring that everyone is compensated while minimizing the number of transactions required. Now that we have our heap set up, let's walk through the process of simplifying transaction step by step. We'll take the first value from each heap, create a table to track who pays whom, and if there is any remaining balance, we will place that value back into the heap. And we will repeat this process until everything sums to zero. First transaction. Taking first value from each heap. First, we'll take 10 from D and give it to B, clearing D's debt and balancing B's owed amount. Note: both heaps restructure themselves after we take out first nodes. Second transaction. Next, we take $5 from A and pass it to E. This clears A's debt. Though E still needs $5 to settle up, we'll put him back into the heap. Third transaction. Finally, we will take $5 from C and give it to E, fully clearing both C and E's amount. Now both heaps are empty, meaning all debts are settled. This step-by-step process allows us to simplify transaction effectively while keeping track of who pays whom. It shows us how heaps helps us quickly access the highest and lowest values, minimizing the number of transactions and making everything balanced. Now let's check how many transactions we save. We started with this graph, and transactions according to this graph will be this. Before using Splitwise, we would have to make 6 payments, but now we have to make 3. And this is how we minimize transactions. Hooray! We have successfully navigated through the world of heaps and discovered how they help us in calculating minimum transactions in simplifying debts. Thank you for joining Breakdown Box on this journey through heaps and debt simplification. If you found this video helpful, please take a moment to like, subscribe and share it with your friends. Your support helps me in creating more content like this. If you have any questions or want to learn more about heaps or any other topic, feel free to leave a comment below. Until next time, keep breaking it down.